Hi, welcome to this introductory presentation on Space Management Solutions with Tivoli Storage Manager. Today I'm going to cover why space management is important, how space management works in the TSM environments, and then finally we'll go into some high-level details on the two Tivoli Storage Manager space management solutions. The first being TSM for Space Manager, which works in the UNIX environments. The second being HSM for Windows. So space management is an important concept because there is a lot of data that's out in environments that once it's been created and maybe been used for a few months or something, it suddenly becomes inactive data. And at this point, the initial value of that data is no longer able to justify it being left on expensive primary disk underneath a server. Users want to be able to automatically manage this data and move it to less expensive storage, but if they need to retrieve it, they still want to be able to access it without having to go through a long process of finding it and pulling it back. Another downside of this extensive growth of data out on primary disk storage underneath your production servers is that, first of all, the cost. Second of all, the expense of being able to keep that disk spinning and up and active. The time it takes to do backups and restores of very large disk subsystems, or if you had a disaster, the time it would take to recover that from scratch. And finally, the response time on disk file systems tends to drop off as they get larger. So what the solution for this is Tivoli Storage Manager is able to take these inactive files and automatically migrate them off to less expensive storage. And all of this process of identifying the files to be migrated, migrating the files, and then, if need be, being able to retrieve them, that entire process is automated. So who needs space management? Places like hospitals that keep a lot of x-rays that need to be kept online. Industries that do photo album repositories would want to keep those files online initially, but then migrate them off to cheaper storage after a certain amount of time has passed. Perhaps engineering firms or other places that have large blueprints or types of scans that go along with oil drilling. Perhaps lawyers' documents. So a lot of industry has these large files that need to be able to be accessed, but at the same time, they're not necessarily being accessed every day. So these industries want to be able to get lower cost of storage. They want to be able to optimize the way that they store their data so that active data that's being frequently accessed is on the more expensive, high-speed disk, and inactive data is being moved off to lower cost storage. And this in turn will improve the availability of their active disks and the speed at which those disks can be backed up, as well as the speed that if there is a disaster that they can be restored. And of course, all of this needs to be automated. So let's see how Tivoli Storage Manager works with space management. So with Tivoli Storage Manager, first of all, I want to clarify the two definitions of hierarchical storage management. The first being the one we're going to be talking about, taking end users' data and migrating it to the Tivoli Storage Manager server and being able to seamlessly recall it if it's needed. The second term that is associated with HSM has to do with the TSM server, where we can take data that was originally backed up to disk and then migrated out to tape, and then if a new tape drive is introduced, move that data out to that new device. We're not covering the second piece in this presentation. What I'm focusing on is the taking of end users' data and migrating it to Tivoli Storage Manager into that storage hierarchy. You'll also find that other customers will utilize different terms around space management. Some people will refer to these as archived files, but inside of Tivoli Storage Manager, we use archive files under a different term. When we refer to archive files, we mean files that have been sent to the TSM server to be kept for a specific amount of time. For instance, tax records that have been sent to Tivoli Storage Manager to be kept for 7 years and then expired off. We also have the term data retention. Data retention meaning you have sent them to the Tivoli Storage Manager, and we're keeping them for regulatory requirements for a specific amount of time. What we're focusing on is the space managed files. And what this does, once again, is it goes out to the production servers, it identifies files that fall into a specific category, it migrates those to the Tivoli Storage Manager server, and these files, once they've been migrated to the Tivoli Storage Manager, are kept until the original file is deleted off of the primary server. These files are also readily accessible, so if a user does go and try and access them, they will automatically be recalled from the Tivoli Storage Manager server and opened up into the application, versus the archived or data retention files where you'd actually have to go through a separate interface to do a retrieve or restore of those files. So what exactly does space management do? First of all, it scans the file systems where space management has been set up, and it identifies files that meet the space management criteria. And we'll talk about that criteria here in a bit. It then takes these files and it copies them over to the TSM server and the TSM server storage pool, where it stores them. Then it replaces the original file on the production machine with a stub file. And a stub file is just basically a little placeholder. If we go out and you do a df or do a dir on that directory, it looks like the file is still there. You'll see the file name and the information about that file. However, the actual file has been replaced with just a small little stub file. The entire file is once again sitting out on the Tivoli Storage Manager server inside of its storage hierarchy. If a user needs to access this file, and either the user directly issues an open against that, or some application issues an open against that, that file is retrieved from the Tivoli Storage Manager server, brought across the network, and then put back in place on the production file server. And then, of course, that application can then open it and utilize it. All of that happens seamlessly. The way that it happens is if you've got little daemons out there which see when an IO request is issued against a stub file and actually do the recall from the Tivoli Storage Manager server. The value of the two solutions we're going to talk about is that it automatically identifies and moves these files from the production servers over to the less expensive storage that Tivoli Storage Manager is managing. Then, should that file be needed, those files are automatically recalled back and put into their original location. On this slide, you'll see the basic architecture of this solution. Up top, you have your production machines. These would be your file servers, your workstations, whatever machines have the data that you want to space manage. On these machines, you've also installed the space management code. If it's a Windows machine, you've installed the TSM HSM for Windows. If it's an AIX or Linux machine, you've installed the TSM for space management code. These machines are attached via the LAN or the SAN to the Tivoli Storage Manager server. And the Tivoli Storage Manager server is a dedicated machine that consists of a DB2 database to store the meta information, and then some combination of disk or tape or VTL, or maybe just disk or maybe just tape, that creates the storage hierarchy where the actual data will be stored. Let's take a look at now how these solutions are set up and the parameters that are used to determine which files are migrated from the production machines over to the TSM servers. Okay, now let's take a look at the specific details for the two solutions. As you'll see, the two solutions have slightly different parameters and slightly different interfaces when it comes to setting up and working with the space managed files. First, let's take a look at the TSM for space management, the UNIX solution. For the UNIX environments, the first thing you would do is you would set up an include-exclude list about the types of files you'd want to migrate. Perhaps you only want to migrate JPEG files, or perhaps you want to exclude .doc files from being migrated. You can set that up to meet your end user's needs. Second, you're going to decide on a migration order priority. And this is basically a formula that combines the age of the files and the size of the files. So you'll set up an age and a size factor. In addition to the migration order priority, you'll set up migration quotas. And these are quotas that are based on the file system utilization. So you'll want to set up a quota for the high level. Once your file system reaches this high threshold, we'll then take a look at the files underneath it and figure out the best ones based upon the priority formula we just talked about. And it'll migrate those files until you hit the low migration threshold. We also have a pre-migration quota. Now what pre-migration does is it will actually start migrating and copying the files over to the Tivoli Storage Manager server prior to that high threshold being reached on the file system. So we pre-migrate the files over to the TSM server, but we don't replace the original file with the stub until the high threshold is met. When the high threshold is met, we can rapidly turn those pre-migrated files into stub files and therefore free up the space. Another option you have is the stub file size. So when the original file is replaced with a stub, you can determine how much of that file is actually left in the file system. Now the default is the file system block size minus 1 byte. But there's actually some programs which can glean enough information off of the first part of a file in order to, for instance, obtain details about what's in that file, maybe details about what that X-ray is or who it belongs to, or other critical stuff that would reside at the beginning of a file. So there are applications which can look at the stubs and know right away, is this the file I'm looking at or no? And if it's not the file, it'll move on and a recall will not be required. So there is a lot of reasons to actually have a stub file that might be of different sizes depending upon the type of data that's out there and which applications might be accessing the files. So the migration candidate list will be kept current so that when migration is needed, we can rapidly look at the migration candidate list and determine which files should either be turned to stub files because they've been pre-migrated, or which files need to be migrated over to the TSM server. Now, files are candidate for migration if they are regular files, if they do reside in the file system which we have set up for space management, if they haven't been excluded for migration, and if they meet the management class requirements that have been set up. And then obviously the size has also got to be larger than the stub or block size that's been set up. Then we go through and we look and we choose them based upon the size and the age and the formula we talked about on the previous page. The files can be in 3 different categories. They can be considered resident, which means that they reside on the production machine. They can be considered as migrated, which means they now only reside in the TSM server and the stub file is what resides on the production machine. Or they can be considered pre-migrated, where a copy of the entire file resides both on the TSM server and in the original production file system. There are different ways to kick off migration. Normally people will have it set up to automatically kick off based upon the high and low thresholds. The nice thing here is if you have set up pre-migration, if your high threshold is reached, we can rapidly turn those pre-migrated files into stub files and thus free up the file space very rapidly. We can also do a selective migration where we select an individual file and say, let's make this candidate and just move it off right now. Here's another chart that goes over the file system states where we have the resident copy that only exists on the local file system. We have the pre-migrated file which exists both on the file system and in the TSM storage pools. And then we have the migrated copy where only the stub file exists on the production file system and the actual file resides in the TSM storage pools. Now when a user needs to access a migrated file or an application needs to access that file, these files will be transparently recalled from the TSM server back to their original location. Now there are certain Unix commands like issuing an ls or a find or a df or a du which will not cause a recall. And there's also different applications which can just look at the information resident in the stub file and not need to retrieve the entire file. We can do a selective recall where perhaps you know that you are going to need these files which are necessary for the production of a specific film. And so you'd recall all of those files and have them sitting back in the file system prior to the production of that film occurring. When you do a recall, there's a couple different recall modes. The first mode is normal, where we wait for the entire file to be read back from the TSM server and to be copied to the original location prior to having the application utilize it. We can also do a streaming mode, where as the file comes back from the TSM server, the application gets that additional bits and bytes. Or we can just do a partial file recall, where only a certain amount of the original file is recalled to the TSM server. Another necessary process with space management is reconciliation. This is what's going to make sure that the files that the TSM server have match the stub files that are out on the production machine. And so we basically are synchronizing the local space managed file systems and the TSM storage pools. So we're checking for things, for instance, of files that have been purposely deleted by the end user. We're looking for files that have been marked for expiration, or where we have an orphaned stub file where the stub is out there but it's not in the TSM server, as well as going through and updating the number of migrated or pre-migrated files. So this reconciliation runs automatically. It's usually a scheduled command. However, if for some reason you need to do a on-demand reconciliation, you could also kick it off. Space management is not backup. It is critical that backup is taken into consideration prior to implementing space management. The most effective way, and what we recommend, is for files to be backed up prior to being migrated. In fact, you can even set up an option that says don't ever migrate files unless they have been backed up. With the Unix solution, we never will back up a stub file. So if the backup encounters a stub file, what it will do is it will go into the TSM server, find out where in the storage hierarchy that file exists. It will actually make a copy of that migrated file over to the backup storage pool, all without having to recall the file back to the production server. Now, if you did have a disaster on a production server and you lost the server and had to restore from scratch, you do have a couple options. You can just choose to restore the stub files, which would be your fastest option. That would also make sure you had enough space. The other option is you could go back and do a restore of the full file. However, you might not have enough space on that if you've migrated quite a few files over to the TSM server. So most customers will just restore the stub files back if there is a disaster that requires a restore of files. This is the Enterprise Space Management console, where you can see which file systems are being protected on which machines. And it gives kind of a centralized location and configuration of the Unix TSM for space management. In summary, IBM Tivoli Storage Manager for Space Management provides space management for the Unix file systems. The way that it's set up is you first of all select the file server you want to manage. You set a high and low threshold for those file systems. Then you set up information on your priority, whether you want to migrate files that are older or larger. You set up your pre-migration levels. You determine where you want to migrate those files into the TSM server hierarchy. And then you just let the system take care of the rest. And it will go out and it'll identify the files, replace them with stub files, and should an end user need that file, it'll automatically recall it. Let's take a look now at TSM HSM for Windows. The criteria for selecting files in the HSM for Windows solution is a little bit different from the Unix solution. First of all, you're going to create some jobs, and these jobs are going to be rules that are used in selecting which files to migrate. And these rules can be a combination of different logical operators and information. For instance, the file names. You can include and exclude directories. You can have file types. You can base the filters upon the creation, modification, last access date, or the age. You can look at size, or you can look at the absolute or relative date of those files. So these different options can be combined with different logical operators to form rules which will determine which files are migrated from the Windows production machines over to the TSM servers. You can also set up thresholds, high and low thresholds, to determine how many of the files will be migrated over to the TSM server. With HSM for Windows, there's only a high and low threshold. There is not a pre-migration threshold. This picture shows files before migrating. You can see that the file size and the size on disk both show up as 9.62 megabytes. On the next slide, this file has now been migrated and replaced with the stub file. So you'll see in this case, the original size was 9.62 megabytes, which still shows up, but in reality, only 4 kilobytes, which is the stub, now resides on the physical production machine's disk. The actual file has been migrated over to the Tivoli Storage Manager server. With HSM for Windows, there's another option. When you migrate files, you can decide to go ahead and just migrate a copy to TSM and leave the original copy as it is on the file system, not even turn it to a stub file. You could decide to replace it with a stub file, like we did in the UNIX, or you could actually delete the file off the production machine and only have a copy out on the TSM server. So HSM for Windows gives you a couple different options of what to do with the original file once you've migrated a copy to the TSM server. There are several different methods to recall files from TSM back to the Windows server. The first would simply be to double-click on the file icon on the production machine, and that would create a recall. You could also utilize any type of application to do an I/O request against that file, which would also cause a recall. You could go into the HSM administrative GUI and issue recalls against that. You could use the Command Line tool to do a recall. A stub copy would cause a recall, as would a stub move outside the file system. So if I tried to move a stub from one file system to another, that would cause the files to be restored. Or I could create a list and have those files recalled from the TSM server back to Windows. This would be a good solution if you knew ahead of time that certain files would be needed in the near future. Now, a recall will not occur if you change the file or stub attributes, if you back that up with the TSM Backup Archive client, being the stub or the original file, if you do a stub move, or if specific virus scanners go and scan that stub file, as long as those virus scanners have the skip sparse file capability built into them. This screen just shows a recall using Windows Explorer, where we simply double-clicked on the file. Here we have it recalling using some type of application to do the recall, in this case Microsoft Word. Here we're using the HSM GUI to go forth and search for specific files and recall the files that match that search. Here we're retrieving using the HSM GUI. This is an example of a command line retrieve. Now, just like with Unix, we also run reconciliation to make sure that the TSM server and the Windows machine where migration is being run are in sync. Just like with Unix, this reconciliation can be scheduled. It will go through and compare both the TSM server and the stub files on the production machine. And the way that we actually do this on Windows is we use the volume shadow copy services to help with the reconciliation. TSM HSM for Windows also has integration with backups. However, it's slightly different than the Unix solution. The first option you have is to skip backing up any migrated files. The second option is if a file has been migrated but not yet backed up, that file can be temporarily retrieved from the TSM server and then backed up. Or if the file has already been backed up, but for some reason the local reparse point content is different from the backed up content, then we can choose to back up the stub file again. And in this case, the actual stub itself is being backed up. TSM will make sure that that stub copy is not expired until the original file is also expired off of the TSM server. So it does link the stub copy together with the original backup. When we restore the file, you can choose to either restore the file or the stub. If you choose to do a selective backup or an archive, that's always going to recall the stub file prior to the backup or the archive occurring. In summary, HSM for Windows does migration a bit different from our space management on UNIX environments. The first step you're going to do is create some jobs that combine the attributes you want to do file migration on. This can include things like the size of the file, attributes, file names, file types. You then will set a high and low threshold for the file system. You can determine where in the TSM server you want to send these migrated files. You can then determine how you want to integrate backups and migrations, if you do want to allow the backing up of stub files, or if you want to force the files to be recalled if they are not backed up prior to being migrated. And then just like with Unix, you'll let the migrations and recalls occur automatically. This slide goes through and details the differences between the HSM solutions. One piece I didn't talk about was when a Unix HSM is utilized, we are actually putting this into a special space management pool on the TSM server. Whereas when Windows does its migrations, these files are actually considered archive files. In summary, TSM for space management and HSM for Windows take inactive files and migrate a copy of them to the TSM server. They then have the ability to replace the original file with the stub file. If a user needs those files, an automatic recall occurs and the file is brought back from the TSM server into the original location of the file on the production server. The nice thing about this whole process is it frees up space on your production servers by moving inactive data to the TSM server. This whole process is policy managed by the TSM server and has integration points with the TSM server backups. The benefits to the end user are improved response times of file servers by offloading inactive data, the ability to move low activity or inactive files to cheaper storage, and therefore use existing assets more effectively on your production machines. Thanks for your time today. Please do take the time to listen to other presentations we have covering other topics in the Tivoli Storage Manager family of products.